Hi, this is Jamina and this is a discussion on parallel systems for IS 215. Working parallel as a group is a very efficient way to reach a common target. This principle is what lies behind parallel systems. Large problems are split into smaller ones and being solved concurrently. Parallel computing allows us to solve data-intensive problems encountered in many areas of science, engineering, and enterprise computing. It also reduces the time required to obtain solution and avoids system failure if one of the processor cannot proceed with the computations. So, take for example this data input. In single processing systems, there's only one processor carrying the workload to provide the desired output. So what happens if the volume of data to process grows significantly, thousandfold or even more? That it would take a really long time to arrive at a solution. A kind of standard response before is to increase computing capacity either by more sophisticated processor or more storage. However, there will always be limitation in transmission speeds and even budget. More hardware means more money needed. Parallel computing is a sophisticated approach to break beyond these limitations. Given this heavy workload, a parallel system divides the workload to several processors using a hashing algorithm. The processors then execute instructions at the same time to their assigned workload. All the output is then integrated to provide the solution sought for. Now let us try to differentiate parallel systems from distributed and network systems, which we learned earlier in this class. Each system was designed for a different main focus. So for parallel, it's for performance, specifically for scientific computing. For distributed systems, main focus is reliability and the ability to share resources. For network system, it's more on access to data and resource sharing. Parallel and distributed, both of them would have low autonomy because the jobs are coordinated between the processors, while for network system, there's high autonomy because there's a local operating system at each node. For the interconnection between the processors, for the parallel systems, it is of higher level. It's order of TBPS, while for distributed, it's usually order of gigabytes per second. For network systems, it really varies depending on networking media, topology, and the protocol used. For physical location, for parallel systems, usually they should be physically close to each other for the system to run. And then for distributed and network, it can either be local to global depending on the usage. And then for memory, for parallel, it is usually shared. For distributed, usually the memory is not shared. And for network, it's also not shared because each operating system or each computer would have its own memory. So that's the end of the discussion for parallel systems.